Hello everyone. In this video we'll look at an example of a radical expression in which we're trying to rationalize the denominator. So if we go ahead and break this radical up into two radicals using the quotient rule for radicals, we'll end up with the square root of 45 x to the 9 over the square root of y to the 7. So in order to rationalize, we know that we need to multiply the numerator and denominator by a certain expression. So the question is, what expression should that be? Now, if you look at what y to the 7 is, notice it's basically 7 factors of y, right? That's 1, 2, 3, 4, 5, 6, 7. Now, that itself is not a perfect square because notice we have a perfect square here, one here, one here. So it's missing one y in order for it to become a perfect square. If I had just one more y, see, then these two would then also form a perfect square, and I would end up with y to the 8, which of course I know is a perfect square of y to the 4, right? So the expression that I need to multiply by is not going to need to be all of the square root of y to the 7. If I simply multiply by the square root of y, and of course do the same on the top, I'll be able to get this done. So watch what we end up with on the top. We end up with the square root of 45 x to the 9 y over the square root of y to the 8. Now, so the denominator now is fully rationalized. We know that the square root of y to the 8 is just y to the 4, because remember, the square root of y to the 8 is the expression that you have to square to get y to the 8, and we can see here that's y to the 4. So that's going to become y to the 4. Now the numerator we need to simplify, so we'll go ahead and break it up into two radicals. In one we'll put the perfect square factor of this radicand, and in the other we'll put whatever non-perfect square factor is left. So 45, if we take a quick look at it, we know that 3 goes into it 15 times, 3 goes into that again 5 times, and then 5 will give us 1. So we can see the prime factorization of 45 here, and there's a perfect square of 3 in there, which is, as you know, 9. So we can go ahead and put 9 in here, and we can put 5 in there. So we put 9 in the perfect square radical, which we broke this radical into, and the 5 goes into the non-perfect square part. Now x to the 9, you know how much of it is a perfect square. Well, if you look at x to the 9, once again, that's 1, 2, 3, 1, 2, 3, and then another 1, 2, 3. Notice there are 9 factors of x, so we know that we have perfect squares all along there. So, and of course the product of perfect squares is the perfect square. So 8 of those factors, so in other words x to the 8 is going to be a perfect square, and that leaves an x. So we're going to put x to the 8 from x to the 9 into the perfect square radical, and we'll put the leftover x here into the other radical. And of course y has no perfect square hidden inside it, and it is not a perfect square itself, so that will just go into the non-perfect square one. And then we'll end up with, now we know the square root of 9 is 3, and we know the square root of x to the 8, just like we showed here for y, that's going to be x to the 4. And the square root of 5xy will just carry over y to the 4. And that's how we simplify an expression like that, by rationalizing its denominator and also simplifying anything else that's left. So be safe until we meet again.